folding to try to listen up. All right, so today we're going to talk all things percents, okay? So we're talking about percents, and then we're doing two sections, and then in 210 we're going to talk about the percent change, okay? So whenever we're talking about percent problems, and this again, kind of like yesterday, this is a super great practical application. So whenever you wonder, like, how am I going to use this in real life? This is it, right? Percents, if you're looking for sale prices or anything like that, whenever you see that like a toilet paper roll has 30% more sheets or something like that, this is what it is right here, okay? So we're going to learn a couple different ways to solve percent problems. My preference is the percent equation. In a way, I kind of adjusted a little bit, but I'm going to go ahead and show you the percent proportion. It's pretty straightforward. I think it's pretty easy to use. The downfall of the percent proportion is it is hard to use. It's hard to use when it's a word problem. I have a lot of students that struggle with this when it comes to a word problem. So there's 2% proportions. I have one on here. I'm going to have you guys add another one on here. But okay, percent in general. Whenever I say the word percent, a percent is a number or ratio expressed as a fraction of 100. The denominator of a percent is always 100. So 15% is 15 per 100. It means that if 15% of the class is blonde, there may not be 100 of you in here, but if I were to keep the same ratio, right, and there were 100, there'd be 15 people that were blonde. Okay, so 15 per 100. There may not be 100 people in there, but that ratio would be the same. Okay, so how we can solve a percent problem, we can use the percent proportion. So there's 2% proportions. I have this one right here, but the one that's easier to use is this one that says is over of equals percent over 100. If you're doing the problems like we're doing today, and you're going to do the percent proportion, I would use the is over of. Now, here's the thing. If you are going to do a word problem, is over of doesn't work because the is and the of aren't going to be in the right spots, and I'll show you what I mean by that. So if it's a word problem, you're going to have to use part over whole, which, think about it, the 15%, 15 blonde people, that's just part of the whole, right? All of the 100 people, okay? That's exactly what a percent means. So to use the percent proportion, if you're going to do is over of, I'll show you how to do that. It's super, super easy. But if you're going to do it with a word problem, you have to kind of look at the information you're given, decide is the information I'm given, is it a part, a whole, or a percent, plug them into the correct spot of your proportion, and then solve using cross products, okay? So for this first one, if I wanted to decide what percent of 50 is 12, okay? Now some people can just see this and go, oh, well this one is the part and this one is the whole, I got it, okay? That's kind of hard for some people to do, and it's really hard for me to teach you because I'm one of the people that I'm just like, oh, well I know which one's the part and the whole, but I don't know how to explain how I know that. So instead we're going to use this is over of. Okay, so my proportion is going to say something over something equals something over 100. Is over of equals percent over 100. The easiest gap to fill in is the number over 100. The only thing you put over 100 is a percent. Neither of those is a percent, so I'm not going to put a number there. This is actually where my variable is going to go. Because he asks us what percent, that's where your variable is going to be. Okay? Now, I have to figure out where the 15 and 12 are going to go. All right? Now, remember, this side is over of. So when it says what percent of 50, that 50 is my of. And then when it says is 12, the is my numerator. Is over of equals percent over 100. And then just like we did yesterday, once you set up your proportion, we're going to use cross products to solve. So 12 times 100 is 1,200. 50 times x is 50x. And then divide by 50. You can slow my notes here. Okay, and that's going to give you 24. Now here's the thing. It said what percent. If you just say 24, 24 is not a percent. So it's kind of like a label. You got to make sure to put that percent sign there. Except 24 and 24% is a totally different number. You have to have the percent sign. Do what? Right, this is 0.24. You're exactly right. 24 is 24. It's a totally different number. Okay, let's try it again. So we have, what is 45% of 150? So first thing, you can set up your proportion. Is over of equals percent over 100. So something over something equals something over 100. The only thing you put over 100 is a percent. Am I given a percent? This time I am 45%. So I'm going to put 45 over 100. Great. Okay. Now my other number, that 150, I have to decide if it's an is or an of. Well, if you read it, it says of 150. And it's is over of, so that 150 is going to go in my denominator. The empty gap where I don't have anything, that's where your variable goes. And then you solve it the same way. Remember, guys, when you multiply up and across, these are equal to each other. So you're going to take x times 100, which is 100x. You're going to take 45 times 150, which gives you 6,750. And then to solve for x, we're going to divide by 100, which just moves that decimal 2 places. So you get 67.5. Now this isn't a percent, so your answer is just 67.5. Okay, last one. Okay, where it says 40% of what number is 20. Same proportion. That's what I like about these. Use the exact same proportion every single time. So is over of equals percent over 100. The percent is the easiest thing to fill out. Am I given a percent? Yeah, they give me 40%, right? So it's going to be 40 over 100 because that's what 40% means, 40 over 100. Now the 20, see how it says is 20? It's is over of, so it's going to be 20. I don't know my of, so it's going to be 20 over x. And then same thing, we would use our cross products. So 20 times 100 is going to be 2,000. X times 40 is going to be 40x. Divide by 40, and that should give me 50. My answer is 50. Okay, that's the percent proportion. Very easy to use, and if the problems are written like this, which they are all going to be written like this, I think except one today, super simple, is over of. Now, if you're more of an equation person, you can also use the percent equation. Now, I don't really use this in a sense, not for these types of problems, but really what you can do is, let's say we have, there's a sale, okay? It's $20 for a shirt, but it's 15% off. To figure out how much you're going to pay, you need to take the whole, the $20, times the percent. Okay, the whole times the percent. That's how you would do that, okay? That will tell you what part you are going to save. So, pretty much, okay, so I guess it says, if I take 20% of 100 cookies, you'd have 20 cookies because 20 is part of the 100. Now, what I like to do instead is I like to just take this and pick out the math keywords and write an equation. Now, notice that these are the same problems, so we should get the same answers. Okay? Here's what I like to do. What percent? What? I don't know. In math, if we don't know something, what do we use? The variable. So it's going to be x, and keep in mind that that needs to be a percent. Okay? Of, what operation is of? It is times. So x times 50, what percent of 50 is, what does the word is mean? Equals 12. Hey look, I've got an equation that says x times 50 equals 12. If I want to solve for x, I need to get rid of the times 50. How would you get rid of the times 50? Divide by 50. So we would end up with, now here's the thing, that's going to give you 0.24. Here's the thing with percents. Thinking back to the last time you worked with percents. When we are actually multiplying with percents, like in this equation, if I knew what x was, I wouldn't plug in the percent, I would change it to a decimal. This is the decimal form. So for the percent equation, you have to then change this into a percent by moving the decimal 2 places to the right. So your answer is 24%. Same answers we got over there. Okay, let's try this one. Okay, this one says, what is 45% of 150? Okay, what? What do we use for what? X. Is means equals. Is means equals. Now the 45%, remember what I said? We're not going to plug in 45 because that's a percent. We don't multiply with percents. I need to turn that to a decimal, which is going to be 0.45. So 45% of, what does of mean? Multiply 150. Now this one's nice. The percent equation for this one's nice because it just says, well, to find x, take 0.45 times 150, and when you do that, you're going to get 67.5. Same answers over there. And then the last one, if I have 40% of what number is 20? Okay, 40%, we don't want to plug in 40, we're going to plug in 0.4. Of means to multiply. What number, going to use x, is equals, and 20 over there. So you're solving for x, remember, so I need to get rid of the 0.4. It's 0.4 times, so to get rid of that, we're going to divide by 0.4, and you would end up with 50. So I think the equation is probably a little quicker, but if this didn't make sense how I'm picking out those keywords, and you're like, I have no idea how you did that, that's fine, use the proportion, okay? All right, the other two things that are related to this, okay, I mentioned kind of tax, discounts, and interest, okay? Tax is a percentage of the cost that's added to your total. So if you go buy a pair of shoes for 50 bucks, you're not going to give the cashier 50 bucks and walk out, right? You have to pay sales tax. In Kansas, it's around 7% depending on what city you're in, okay? What that means is you have to pay 7% of the $50 to the state. But then you also have to pay $50 for the shoes, right? So you have to pay $50 plus 7% of $50, okay? The same thing happens when you have a discount, like if you have a coupon. For my example, like if you bought a $20 shirt and it's 15% off, you don't have to pay 15% of the cost. Okay, so you have to find 15% of the cost and then subtract it. Okay, and then the last thing, and this one, is this idea of simple interest. We're going to learn later on this year about what's called compound interest. And whenever we learn about compound interest, you're like, why would you ever put something in a simple interest? There's purposes. But to find simple interest means you put your money in a bank, and they're going to pay you to put your money in their bank. Because what they go and do is they then lend your money to somebody else. I know, it's crazy. That's how banks work, though. So they're going to pay you for letting them use your money. Okay, it's still your money. You're still going to get your money. But since somebody else is using it, that's why they pay you interest, because they're lending your money out to somebody else, and then they're making money off them because they have to pay a fee for lending it. So to find that, to find how much interest, that's the money they're going to pay you, you have to take P, which is the principal. That's how much money you're putting in the account, how much you start with, okay? Times your rate, which is a percent, and then times the time, how long it's in there. Okay, so let's look at one of each of these. Okay, so this first one here says I buy a pair of shoes for $75. Like we talked about, though, you can't just hand the cashier $75. She's going to say, you're missing some money. Okay, this tax rate is 7%. So what you need to do is you need to first find the tax, how much you're going to pay in tax. So you're going to take the tax rate times the cost. So in this case, I'm going to take 7% to find the tax. I'm going to take 7%, but, guys, we're not going to use a percent. We're going to use a decimal, so it's actually 0.07. Times the cost, which is 75. And when you do that, you're going to get 5.25, which is $5.25. That means you have to pay $5.25 in tax. Now the question though is asking, what's the total cost? Well, here's the thing. You're going to pay $75 for the shoes, and you're going to pay $5.25 for the tax. You are going to pay $80.25 for the shoes. Now, when there's a sale, you do basically just the opposite, okay? So if I have a coupon for 15% off the haircut normally costs $24, okay? But my coupon is 15% off. I don't have to pay 15% of the cost. So the first thing we have to do is figure out what is this discount. Okay, how much money am I saving? And you're going to do the exact same thing. You're going to take the percent times the total. Okay, so I'm going to take 15%, but not as a percent. It's going to be a decimal, 0.15, times, it would normally cost $24. Now that's going to give you 3.6. What that means, you are going to save $3.06. You don't have to pay $3.06. So to find the total cost, you normally would have to pay $24, but with the discount, you don't have to pay $3.06. So you are going to pay $20.40 for that haircut. Where is it?
Is the answer to that, is that
80-25, yes, 80-25. Okay, and then lastly, okay, so you deposit $800 into a savings account. It earns simple interest at a rate of 5% per year. How much interest will you have after 5 years? So to find the interest, okay, there's 3 parts to finding the interest. Okay, you're going to take your principal, PRT. Principal is how much money you put in the savings account. You put $800 in the savings account. Times, okay, the rate. That tells me that I have a simple interest rate of 5%. Just with everything else, I don't plug in 5%, I turn it to a decimal, so it's going to be 0.05. And then T is for time, so it would be 5 years. Now when you multiply those out, you would get $200. That bank is going to give you $200 for letting them use your money for 5 years, which is really not a great deal. Still, $200. Okay, better than sitting at home in your dorm. Okay, questions on that? Okay, the last thing is called percent change. Now, here's the thing about percent change. It's just another way of thinking how I think about it of discounts and tax. Okay, so over here, when I say that you're going to have to actually pay $80.25, that difference, that change from the original, which was $75, to which you actually have to pay $80.25, that change is a 7% change. Okay, that's what percent change does. Okay, percent change tells you, okay, here's how much it's changing as a percent. Because here's the thing, I could just say, all right, well, you know, for those shoes, okay, I had to pay $5.25. Okay, which is a 7% change. But if you just say, okay, the tax, and you don't really know what you're talking about, is $5.25, that may seem like a lot of money. I mean, $5.25 as far as like a pair of shoes, it seems like a lot. But here's the thing. If you're buying a car, okay, and the change was $5.25, that'd be nothing, right? Because it's so much more. So, percent change expresses the change as a ratio of the original cost. So percent change is super easy to find, okay? You're going to find how much it changed and divide it by the original. That's it. How much did it change? Divided by the original, okay? So like this one, it says you were hired at a wage of $8 per hour, but after a raise, you're now making $8.75 per hour. What was the percent increase? So you need 2 things. You first need the change. So from $8 to $8.75, what was that change? 75 cents, 0.75. Now you're going to divide this. This is the important part. You're going to divide this by the original, which was $8. Now when you do that, it's going to give you about 0.094. That's a decimal. I want my answer as a percent. So if I move my decimal 2 places, it'd be a 9.4% change. It's a pretty decent raise, honestly. Okay. Okay, the price of gas in 2010 was $2.79. I should say today, this was last year, so it was a year ago. The price of gas now is way more expensive. It's about $1 more expensive than that. So I should have changed that. So this was last year, okay? The average cost of gas last year was $2.18. What is the percent decrease? So this time it's a decrease. Now it doesn't really matter because in the numerator, you just need to find how much it changed. Now, you may not be able to just say, oh, from 279 to 218, it is. What would you do to find the change? What operation? Subtract. Yeah, so you take 279 minus 218, that would give you 0.61. It was a 61-cent change. Now you're going to divide that by the original, the first one, which was 279. Okay, now that's going to give you about 0.219, which is a decimal. You don't want a decimal. You're going to change it to a percent, which is going to be about 21.9%. Once again, this was last year. Today it would actually be a percent increase because the price of gas is closer to like $3.18 now. Okay? All right, let's get this glued into page 27 of your notebook. Is that right? I think. Is that right? No. Oh, that's last year. What page are we on? Sorry, page 23. I was using my notebook from last year. 23. This is 2.9, 2.10, percent, and percent change. The equation for all of them and make sure you're getting the same answer. Okay? Alright, so find the missing information. Okay, number 1. What percent of 75 is 15? What percent of 75 is 15? Okay, so for this first one, we're going to use the percent proportion. The percent proportion says is over of equals percent over 100. Guys, the easiest gap to fill in is the percent over 100. But do I have a percent? No. That's where your variable goes. Okay? Now it's is over of. So when it says what percent of 75, that's going to go down here. Is 15, that's going to go up there. Once you set this up, then you're ready to solve for x. So we're going to use cross products. 15 times 100 is 1,500. Multiply up and across the other way. 75 times x is 75x. And then to solve for x, divide by 75. When you do that, you are going to get 20. Now here's the thing. Here's what I like about the percent proportion is it gives you your answer as the answer you need. 20, in a way, is your answer, but remember it's asking me for a percent. For the percent proportion, all you have to do is throw the percent sign on it. You don't have to change it to a percent. Because here's the thing. The 20 is over 100. The 20 already is a percent. Okay? It changes it for you. Number 2 says, what is 34% of 82? What is 34% of 82? Okay, now, we're going to use the equation for this one, so we're going to pick out the key math words, okay? What, that should tell you that's your x, is, always means equals. Now, for the equation, although it says 34%, in the equation, you can't use a percent. You have to change it to a decimal, so it's going to be 0.34. Of is always going to mean to multiply 82. Now these are ones that I really like using the equation because all you have to do is take 0.34 times 82 and you get 27.88. That one just kind of spits out the answer for you. I think the equation's probably a little quicker, but the proportion maybe is a little easier, maybe. Okay, 2 more of these. We'll go back to the proportion for this one. Okay, this one says 45% of what number is 40.5? 45% of what number is 45? Okay, now remember, to use the proportion, it is over of equals percent over 100. The only thing that goes over 100 is a percent. I'm given a percent this time, so that 45 is going to go over 100. Now, you do not change it to a decimal because, guys, 45% is 45 over 100. It does it for you, okay? Now to figure out where my other one goes, it says 45% of what number is 40.5. Remember, it's is over of, so it's going to be 40.5 over x. And then to solve, we multiply up and across. 40.5 times 100 would be 4,050. X times 45 would be 45x. And then to solve for x, divide by 45. And we should get 90. We should get 90. Okay, last one of these, I will use the equation for this one. What is 20%, sorry, 120%, what is 120% of 60? What is 120% of 160? Okay, so picking out those key math words. What means x. Is means equals. Instead of 120, yeah, 1.2 of means multiply 60. So you're going to take 1.2 times 60 and you would get 72. Okay, how many of you guys like the proportion? How many like the equation? Half and half. Awesome. I don't care what method you use, as long as it makes sense, as long as you can get the right answer. Okay? Now, when it comes to word problems, I'm always going to default to the equation. I strongly encourage you not to use the proportion. I guess I'll show you how you can use the proportion in a way. But the percent proportion, if you try to think is over of, it's not going to match up with the numbers. Okay, I'll show you what I mean by there. So this says a family sells a car for 60% less than they paid for it. They paid $9,000 for the car. For what price did they sell the car? Okay, so here's what's happening here. I don't know if you know anything about cars, but the second you drive them off the lot, they depreciate in value a ton. So I don't know how long this family had the car, but yeah. When they bought it, okay, they paid $9,000 for it. When they exchanged it, right, sold it back, they lost 60% of the value. 60% less. So what I need to find first is how much money did they lose? Not lose, but how much money, how much less did they sell it for? So to do that, you're going to take the percent times the total. I need to find 60% of 9,000. Now, if you like using the percent proportion, you have to come up with this first, 60% of 9,000. But then what you could do is over of equals percent over 100. You could do that. Okay. Now this one's really easy to do though, guys, because of means to multiply. So you're just going to take 0.6 times 9,000, which gives you $5,400. $5,400. And here's the thing. That's not what they sold it for. That's how much money they lost. Okay. They bought it for $9,000. They lost $5,400. When they sold it back for $3,600. Tell you what, buying cars, not fun. I know, yeah. Car business, yeah. They make a lot of money.
What's the on the left side that
No, the left side, you can do this, okay, but if you really like the proportion, you have to come up with this first, 60% of 9,000, okay? So if you wanted to do the proportion, the 60 would go over 100, that's easy, okay? But the of 9,000, that would go there. You get the same answer, okay? So you could still use the proportion, but you can't really take the is over of from the problem. You have to kind of write your own problem in a way, okay? All right, last couple of things. Let's talk about that savings account idea, okay? So you go to a savings account, you deposit $125. It only earns 1.75%, which is probably a little more likely than the example that you guys had on your foldable. After 4 years, how much money is in the account? Okay, so remember what happens here. When I put this money in the account, I earn interest. Okay, they're going to pay me money for letting other people borrow my money. So to find the interest, it's I equals PRT. PRT. P is the principal, the amount of money you start with. R is the rate, okay, but it's not 1.75 because it's a percent. It's going to be 0.0175. And T is the time after 4 years. Okay, now this is not a good deal at all because that interest is only, yikes, 8.75. That means after 4 years, you're only going to make $8.75, which, I mean, I guess it's better than sitting at home in your drawer, but still. Now, here's the thing. The question was asking how much money is in the account. Okay? It's not $8.75. It's $125 plus the interest that you made, which is $133.75. Okay, last two examples here. The percent change, guys, is super simple. Okay? So we're going to decide whether each percent change is an increase or a decrease, and then we're going to find the percent change. Remember, to find the percent change, it's amount of change over original. Amount of change over original. So number 7, let's say we have something where the original is 140 and the new is 126. 140 to 126. Okay, first thing we want to do, we need to decide if it's an increase or a decrease. If it goes from 140 to 126, is that an increase or a decrease? That's a decrease. Now to find how much it decreased, we need to know the amount of change, how much it changed, and then the original. So from 140 to 126, you subtract those two, you get 14. Big thing here, guys, you have to put the original in the denominator, so it's going to be over 140. Now, when you divide those, you're going to get 0.10. This is not a percent. I need it as a percent, so I need to change it to a percent. That's a 10% decrease. And let's do one more. Let's say the original is 2. The new is 4.5. So if it went from 2 to 4.5, is it an increase or a decrease? That is an increase. And then to find how much it increased, we need the amount of change over the original. So from 2 to 4.5, changed by 2.5, over, big thing, it has to be over the original. So over 2. Okay? Now when you divide this out, you're going to get 1.25. Okay? So change this to a decimal, it'd be 125%. Yes?
How did you get 2.5?
So the difference between 2 and 4.5, we don't really care about the sign, because if you take 2 minus 4.5, you're going to get negative 2.5. We don't care about the sign. I just want to know what's the difference. So you would subtract these two. Okay? Any other questions?